friends. Thank you for joining me. Welcome to TJ's Maths Clinic. In today's lesson, we are looking at this very interesting topic in mathematics, sequence and series. In today's presentation, we'll center our discussion on the concept of sequence and series. Very important. Let's look at the concept of sequence. What do we mean by sequence? When numbers when numbers appear when numbers appear or are presented one after the other one after the other one after the other in an orderly manner we refer to the set of those numbers now. We refer to the set of numbers as what? Numbers as sequence. Very important. This is the concept of sequence. When numbers appears or are presented one after the other in an orderly manner, we refer to the set of numbers as what? We refer to those set of numbers as sequence. Very important. So this is the concept of sequence. E.g., let's look at the example. Let's say we have 1, 2, 3, 4, or we have, let's say 3, 7, 11, 15, in that order. What can we see? These numbers follow a certain pattern. From 1 to 2, meaning it has increased by 1. From 2 to 3, meaning it has increased by 1. 3 to 4, it has increased by 1. So this number follow a certain pattern. When a number follow a certain pattern in an orderly manner, we refer to it as what? Sequence. Very important. What about this? 3, 7, 11, from 3 to 7, meaning it has increased by 4. 7 to 11, it has increased by 4. 11 to 15, it has increased by 4. So this pattern of numbers is what we refer to as what? Sequence. Let's look at the concept of series. Let's look at the concept of what? Series. Permit me to clean this. Let me look for something that can clean this very well. Permit me to clean this so that we can look at the concept of series. What do we mean by series? It is summation or the sum of series now. Series the summation of numbers of terms, in a sequence is called a series. It's called a series. The summation of numbers of terms in a sequence is called series. So they are not the same actually. You must have first of all have a sequence before you can have a series. Very important. Like this example here. If I say 1 plus 2 plus 3 plus 4 plus in that order, this is a series. But if there is no this plus, meaning it is what? A sequence. Very important. Or if I have, let's say, minus 3 plus minus 2 plus minus 1 plus in that order, this is a series. Okay, very important. So this is the difference between a series and a sequence. They are not the same. For you to have series, you must have sequence. The summation of numbers of terms in a sequence is called series. Very important. Okay, let's look at types of sequence we have. Basically, types of sequence. Basically, we have two types of what? two types of sequence as far as this lesson is concerned. Let's look at the two types of sequence. Uh, let's write now types of what? Types of sequence. Types of sequence. First, we have arithmetic, arithmetic, arithmetic progression, arithmetic progression, and geometric progression. But we'll look at only the concept of arithmetic progression, which is also known as linear sequence. The geometric progression is also known as exponential sequence. This arithmetic progression is known as AP. The geometric progression, short form GP. Very important. Let's look at the concept of arithmetic progression. Arithmetic progression now, very important. Arithmetic progression is a form of sequence. Is a form of sequence in which is a form of sequence in which each term is gotten by the in which each term is gotten by the addition of the common difference. The common difference preceding one that precedes one. Addition of the common difference. Addition of the common difference to the preceding one. To the preceding one. Okay, let me keep this duster. Okay, arithmetic progression is a form of progression, is a form of sequence in which each term is gotten by addition of the common difference to the preceding one. Very important. What does that mean? What do we mean by the keyword here? Common difference. Arithmetic progression. Let's say we have 3, each now, 3, 7, 11, 15, in that order. Arithmetic progression is a form of sequence in which each term is gotten by the addition of the common difference to the preceding one. Let's look at what's the difference between this. From 3 to 7, from 7 to 11, from 11 to 15, meaning it's increasing by 4. At this point, the common difference D, we use D for the common difference, is nothing but T2 minus T1. T stands for the number of terms. This is the second term here. This is the first term. This is the third term. And this is the fourth term in this sequence. So if we want to find the common difference, just say 7 minus 3, which is 4, or 11 minus 7, which is 4, or 15 minus 11, which is 4. So it will be second term minus the first term, or the third term minus the second term. This is how we can know that whether a given sequence is arithmetic progression or linear sequence. Another name for arithmetic progression is linear sequence. So this is how to find the common difference. Very important. If we look at this number here, we have 3, 7, 11, 15. These are the items that's given. From 3, it will increase by what? 4. Okay, meaning the common difference is 4. That's 3 plus 4. We'll get this 7. Then 7 plus what? 4. We'll get 11. Then 11 plus 4, we get 15. So this is the order. Very important. Okay. Let's look at how we can analyze this very well. Okay, this is how to find the common difference, or this is how to know whether a given sequence is an arithmetic progression. If T2 minus T1 is equals to the third term minus the second term, then that form of sequence is an arithmetic progression. Very important. Let's look at the nth term of arithmetic progression. That's AP now. Before we do that, let's say A represent our first term. To get our second term, it will be A plus the common difference. To get the third term, it will be A plus 2 times the common difference in that order. What do we mean? Let's analyze it means in this example here, A is 3, then our common difference D is 4. Let's see whether it is true. A, which is our first term, is 3. Then the second term now will be A, which is 3 plus the common difference, which is 4. 7. That is 7 now. Can you see we're getting 7? Then the third term now will be A, which is 3 plus 2 times the common difference, which is 4. Very important. 2 times 4, 8. 8 plus 3, that is 11. So this is the general form as far as arithmetic progression is concerned. Very important. Let's look at the nth term of this arithmetic progression. Let's look at the nth term, the general formula now for nth term. Okay? If A, A plus D, A plus 2D are the general form, if these are the general form of an arithmetic progression, then, the nth term of AP, A for arithmetic, P for progression, is given as the number of times T now will be equals to A plus the number of term minus 1 multiplied by the common difference. Given that, let me interpret the terms now. Let me clean here. I hope we are together. Given that this T, A is what we mean by the first term, N number of terms, then our D is the common difference. Very important. D is the common difference. So this is formula number 1. We use this nth term when the last term is not given. But when last term is given, we use last term will be equals to A plus N minus 1 multiplied by the common difference. So these are the two key nth term of arithmetic progression. Then we have sum of AP when the last term is given and when the last term is not given. Let's look at those two concepts. Then in my next presentation, we look at how we can use this formula to solve problems. Very important. Let's move here to summarize the remaining two formula. So let's say, let me remove this type. Sum of AP or linear sequence, they mean the same thing. When last term is given, what will be the sum of AP? Sum, this S subscript N means sum, it will be number of terms divided by 2, bracket open, first term plus the last term, where L is the last term, L represents the last term, very important, and A is the first term, N is the number, N is the number of terms. Very important. This is another formula, very important as far as AP is concerned. Let's look at the last formula. Sum of AP When last term is not given, when the last term is not given, what will be the sum of arithmetic progression? Sum will now be equals to number of times divided by 2. We have our square bracket, uh, 2a plus another bracket open n minus 1 close the bracket multiplied by the common difference. Very important formula. So we have basically 4 key formulas as far as arithmetic progression or linear sequence is concerned. Thank you for watching. As I said before, we'll look at how we can apply these formulas to solve as many questions as we can under arithmetic progression before we dive into geometric progression. Thank you for watching. Please do share this concept to your learning colleagues, and don't forget to subscribe to TJ's Maths Clinic for more amazing and interesting video. In my next video, God's willing, we'll look at more examples from this topic. Thank you for watching and see you in my next video.